And with that, I'll introduce our first speaker this afternoon, who is a man I know well, Fred Yentz, CEO of IoT Platforms with well-known solutions provider Telit. Fred's going to be talking to us about disrupting IIoT with edge intelligence. Fred, welcome. Good afternoon.
Hey, thank you, Keith. Welcome to everybody. Voice sound check is still good?
You're coming through loud and clear, Fred.
Excellent. Well, hello, everybody, and certainly thank you to IMC for hosting such a rich content seminar here. And unfortunately, we can't do it in person, but I'm sure that we're catching a few folks in the virtual space that we may not have been able to see in Germany during the Hanover Mess. So I do appreciate everybody's patience with all these venue changes, and I look forward to taking the time to talk about a topic that's gotten a lot of airtime in the last year or so, which is what's happening at the edge. And with that, I'll begin. So first of all, it's interesting when we think about disrupting IIoT with edge intelligence and edge compute. There's a bunch of reasons for doing this, and I tried to make it simple to make sure that we can communicate in a pretty succinct way in the next 20-25 minutes to think about what is indeed needed. And we'll talk about some elements here and a little backstory on a few of them as well. But we've been manufacturing things for a very long time. We've lived in the world of, Industry 3.0 for a long time. SCADA, MES, compute inside of factories, compute near process points and lines are not unique. But there are some unique things I think that we have to deal with when we start thinking about Industry 4.0 or bringing in the IoT elements. The first thing that I think is important, and for those of you who are truly practitioners in this space, you understand it, but many who enter the IoT domain and want to get to the industrial space, unfortunately, they're not tuned into some of the real needs. One of the real needs is these are real assets. If we think of factories and industrial settings, the traditional methodology there is people purchase equipment, they capitalize it, they depreciate it, they use it frequently until it breaks. Not that all factories have old equipment in it, but all factories have a very wide range of equipment. So connecting to the real world, the world in which manufacturers use equipment to produce goods and services in an everyday manner is something that we have to address. And unfortunately, the real world isn't homogeneous. The real world has a variety of drivers, a variety of legacy protocols, a variety of proprietary and non-proprietary ways to talk to it. So the real world is a very complex and very heterogeneous world. Another thing that's interesting is when we start talking about services that I'm sure other speakers to follow me will start talking about as well. Things like artificial intelligence, machine learning, analytics at the edge. The need to consume real-time data and ingest real-time data is very, very important. We're not looking just for set points or super high-level KPIs. Part of connecting to the real world is understanding how that equipment is operating in real time and then being able to take actions on it in real time. So real-time ingestion or data streaming kind of capability is becoming more and more important as we go forward. Now, when we have this real-time information and this real ingestion of data, we certainly don't want to send all of that information, up into the bigger IT systems or over chargeable or a wide area network into cloud environments. Typically, you'll hear a lot of people talk about edge processing or fog computing or edge analytics. There's lots of ways that this functionality is described, but simply put, you need to be able to push intelligence and actionable business rules, logic, or data transformation and filtering to the edge. So you want to ingest it as fast as you can off the process points in the machines, but you want to take action on it at the layer closest to that ingestion, which would be in this edge compute environment. Now, what's interesting there is, it doesn't mean you throw it away. You might store it there at the edge. You might cache it at the edge. If there's no fault or there's no issues, you might push resultant data up into the environment. If you have something that you want to potentially inspect further, you might go back 3 minutes, 10 minutes. You might go back 1,000 cycles and send that entire data set up to the cloud for incremental processing. But at this point in time, the idea of getting it off the machines, getting it off the equipment that's in the real world and ingesting it into this edge environment is very, very important. Now, as we talked about getting things off the equipment and sending it either to IT environments or to your new, cognitive cloud solutions, it's not one or the other. Every manufacturing and industrial setting environment has what I will generically call their systems of record. That's their existing MES environment, whether that's their existing ERP environment, maybe they're an SAP house or an Oracle house, but they have their systems of record that's how they operate their business. And what they're trying to do is get incremental intelligence, incremental, quicker, actionable feedback into their systems, but they're typically not replacing their IT systems. So focusing on connecting to their systems of record and allowing manufacturers to start exploiting the services and the compute power that you can get from the cloud environments is very, very important. So, the idea is managing both of these is important. The next piece is once we've pinned up infrastructure and we have the ability to connect to these process points and move data, ingest data, move things off of these process points. And most of these solutions are going to be bidirectional. What's important, and it's certainly become more evident in the last 45 or 60 days than ever before, and that's the ability to provide secure remote access. One of our solutions is in the semiconductor equipment space, and we've noticed some of our services being exploited between 30% more and 500% more, depending on the services, because people couldn't go into factories to service equipment. So remote secure access is really a byproduct of some of the value that you get when you deploy in a rich industrial IoT edge and cloud combination pair. We have to realize as technologists and as system integrators that the edge is a tool. The edge is some technology that facilitates people to do their business easier and better with more efficiency. But the edge isn't the reason that they're there. So making sure that whatever we provide to the market as an industry and whatever people in the buy side decide to pick, it has to be easy to deploy and easy to manage. We aren't trying to displace savings and value in other places to consuming all of that energy and deploying and managing at the edge. So easy to use, easy to manage is key. And then fortunately, we don't. Fortunately and unfortunately, we don't always know what the future provides. We don't have roadmaps that go out far enough. We don't have insights into unpredictable global economic or pandemic events like we had this time. But we need to be always ready to think about what this data is going to be used for later. So how do we look forward and how do we stay flexible to where maybe I pivot from a current day system of record, maybe a different cloud technology. And I think about some of the enhancements that we've seen in the way customers think. And I don't think anybody would be offended if you think 5-10 years ago, most factories didn't even like the idea of remote access or remote, moving data outside the four walls of the factory. Now people are leaning towards, connecting with Amazon Azure, Google Cloud Platform, all kinds of things that probably would have never even been spoken of, 5 to 10 years ago. So the future moves fast, the pace of change is quickly, and we need to make sure that we're always prepared on the supply side or on the buy side for where this technology might take us in the future. What's interesting also here, which I find unique, is when people say the edge, it depends on your point of view where the edge is. When I think about the edge, if I'm a controls vendor or a PLC vendor, I'm probably thinking about sensors and actuators on the south side of my PLC. If I am a cloud person, if I'm a Azure or an Amazon or an AWS, frequently I think of the edge as anything not in the cloud. So there are lots of elements in terms of where you might place this technology, and it certainly could be considered the edge, depending, again, on your point of view. And here's where I think we frequently see some disruptions in thinking between what an IT person might think or what an ops person might think. And I think the important thing here is whatever technology you're deploying, whatever technology you're thinking about, you have to think about it being versatile in terms of where it lives in the stack. And I'm trying to just show on this slide, kind of the generic at the very highest level, what you might think of as almost a Purdue-type stack. But the edge might live in multiple layers or in different layers of that stack, not always just at the bottom. Another thing that's interesting to think through, not just in terms of where in the stack these things might be, there's a lot of devices that are becoming very, very intelligent. And these super intelligent devices might end up with direct connection to different layers. One of the things that we've done at Telit is we introduced a concept called One Edge. And our One Edge solution is where people build smart connected products, and there's enough compute and enough, edge technology there that allows them to be products that get deployed in infrastructure and can basically communicate and talk to almost any layer. And that's what we're calling our One Edge technology. And I want to just deviate quickly to talk through this again fast, because what you'll find is the same kind of solutions that you would have in a bigger computing stack, you can also have directly at the edge in a device or a connected smart product, smart service that might be in the manufacturing floor or upstream or downstream from a manufacturing process. So device management, if you have lots of devices, you have to take care of them in managed product lifecycle. You want to be able to do some atomic edge logic to make sure that you're looking at things in that real-time ingestion of data and then figure out where you need to send the information later. You want to make sure, because you have now all these distributed assets, your security surfaces and your threat surfaces might be expanded. So you want to make sure you have things like embedded security managed. Connectivity and services or connectivity service management is important. Many times these kinds of solutions might be upstream or downstream from the industrial factories, but they're very, very important, whether they're on the supply side, distribution, or other. So they might be using different technology solutions, not just the factory LAN, for example, or the production network. And then finally, again, it needs to be able to speak to multiple layers. So here's where we think about the idea of enterprise integration. So, going backwards in this slide, these layers of device management, edge logic, embedded security, connectivity services, they're similar services that you might see at different layers of these stacks, but they're very, very important and very, very meaningful. So moving forward, not only is it the technology or where in the IT stack these things live, but you might start thinking about, I'll do the whole build, where physically these solutions exist. And sorry about the build, guys. The different places where things might exist. We're talking today about, industrial IoT and factories, and you might have a lot of technology in a connected factory, which is what I'll call this very high-level intelligent edge. You might have connected machines. So now I might be connected to a machine that's in my customer's factory, and I want to have remote, secure data collection, management, and edge processing to do things like predictive maintenance or prescriptive maintenance from my service headquarters to the owners of all of my machines that are really in my customer's network. So there's this idea of an edge solution. Then there is potentially connected products. Maybe they're connected pallets. Maybe they're connected services products. Maybe they're connected fork trucks that are in your solution, in your enterprise industrial IoT environment. Or they might even be your workers. So when we think of an edge, there's, again, often many different architectural things to think about. There's services to think about. And then there's what are the process points, what are the people, what are the products or the machines that I'm actually connecting to? Because, again, depending on your point of view, all of these things could be considered, quote unquote, the edge for an industrial company or an IIoT edge set of solutions. But let's kind of bring it back and let's stay focused on just the factory. We won't worry about connected people or connected fork trucks or pallets or the like. And let's stay really focused on what happens in a factory. So one of the things that I find very interesting when we start looking at a factory solution is inside the factory you have to satisfy the operations teams. They're still building tires, they're still building cars, they're still producing petrochemical devices. Whatever their architecture and their output is, they have a set of process points that exist. They have a set of what I will call systems of record inside their factory, but they're trying to leverage services from the outside. The reason that the IIoT element comes in is you want to get services from your suppliers, from your feedback from customers. You want to take advantage of ML or AI or other solutions that might be cloud-based. You might want to enhance your services in a better, more effective way to address problems. So the combination of how do you service your OT teams inside the factory with all the right connections to your devices, your process points, and to your systems of record IT is very, very important. The second element of this is make sure you satisfy the need for IIoT and your IT teams and your business transformation teams and your digital transformation teams. And you've got to get that information out of the factory. And the way we do that is it's a matched pair. There's a device-wise solution that goes in the factory, which you see on the left side of the slide. And there's a device-wise IT platforms element that goes really in terms of how do you orchestrate where this data goes, who it goes to, and who gets access in and out of your factory through this thing we're calling, on the right side of the picture, the IoT platform. Now, what's unique about this, a little bit deeper, is let's take a look at how these things connect. And a little bit of, what I'll call review. We would have real live process points and things, controllers, controller companies, controller OEMs on the left side of this picture. These would be the things that are running in your factory, whether they're torque tools, nut drivers, controllers, companies like Atlas Copco. You see those in almost every discrete plant where you're doing bolt rundowns and screw rundowns with the right amount of torque. CNC machines and your standard industrial control vendors like the Siemens and the Rockwells of the world, Mitsubishi. So connecting to all of those assets on the left side with a library of drivers to, again, check the box to say I've connected to the real world is super, super important. On the right side of this picture, again, more just as an example, is we need to make sure that we're connecting to not only the systems of record, like your on-premise SAP or your cloud SAP, but you might want to be looking towards Azure, AWS. Siemens MindSphere is very dominant in certain places. Companies like IBM have introduced their Watson IoT and their Watson services. So making sure that you can address both, again, the on-premise legacy systems of record and your cloud-based newer technologies is very, very, very key. I've shown a lot of this stuff kind of left to right, right to left. I'm going to try to finish up on one slide that really, I think, kind of hits home in terms of when you think about the edge, what are the different things that can happen? And that's this slide here. And again, if I think about the process points at the bottom, the IT stuff at the top, being able to manage edge compute, edge logic, storage at the edge, remote access at the edge. In the middle, what I have basically is three layers: a device layer, an edge compute layer, and an IT integration layer. When we think about being disruptive, when we think about being flexible in our products, we have two elements. One element would be our asset gateway solution. We have lots of distributed devices, right? These would be things like distribution points or downstream depots, or maybe machines that you're shipped to your customers where you're servicing them, but you're not necessarily allowed on their network. That's traditionally something like an asset gateway, where you would be really leveraging the device access layer to talk to the things, the edge element that allows you to do very atomic, real-time processing of that data, and then a transmission to a remote cloud or service. Not so much worried about IT in that space, because these remote things usually aren't adjacent to the IT worlds, or having their IT systems on the same network. When I think about a factory environment where I have not only the production network, but I have the IT network in the same four walls, then we're going to look at using all three of these layers. So the device layer, the edge compute and logic intelligence layer, and the enterprise connectivity or access layer, so that I can really touch and talk to my systems of record that are not going to get moved out of my production environments at this point in time at all. So this is important when I look at the edge compute, giving people the flexibility to design their own logic flows, their own algorithms, their own actions is very important. And these typically are going to be done by engineers, but not necessarily programmers. So providing a very easy flow engine to be flexible and easy to use, something that I don't necessarily have to compile to use, which allows the craftsman or the OT experienced personnel to leverage them, is very important. It's similar in many ways. You might think of it as a common open source solution like a Node-RED, but this is something where I think we designed originally for the OT people to use this without necessarily, again, the need for a compiled environment. So trying to check the box in terms of flexibility. We don't know what we're going to talk to on the south side or the north side. Flexibility in the middle and easy to use with regard to simple edge logic, etc. Affordable, we can try to manage data flow, ingest at the bottom in real time, but maybe export to the clouds and to the other services as needed in what I'll call right time, with the right amount of data and the right amount of usage to manage costs and complexity. And then finally, providing folks the ability to do remote access into this if needed. I think you're going to have a couple of great speakers following to talk about what kind of AI, what kind of advantages you get to analytics at the edge. Think of this as a scratch pad of a solution that allows you to engage the problem, figure out how to put the right stuff on it, and move it to the next layer. So I'm going to end up, and we'll be passing the baton back to Keith, and he'll be introducing, I'm sure, the next speaker. Thank you, guys.